just cab AC and it is issues. Okay, we'll see one by one. This is a schematic view of locomotive cab air conditioner. You can see the parts afterwards one by one. Just the introduction of air conditioning. Air conditioning is the process of treating air in an internal environmental to establish and maintain the record standard of temperature, humidity, and cleanliness. The air conditioning is the process of treating air in an internal environmental to establish and maintain a standard temperature, that is record temperature. This is the view. If you see from the roof of the cab, you can able to see this air conditioning. This is the view. The refrigeration cycles, how the refrigeration takes place. So we can see the refrigeration cycles. From the compressor, this is the first part. From the compressor, the when compressor starts working, from there it goes to the hot refrigerant is going inside to the condenser chamber. That is a condenser chamber is a heat exchanger. When compressor starts working, the hot refrigerant, it goes to the condenser chamber. We can say that condenser chamber or condenser heat exchanger. From there is a fins are there in this, so it will the warm air will go to the outside. So this is the first is compressor, then hot air comes to the condenser, then the same will come to the expansion valve. Just it is a schematic only expansion valve. From the expansion valve, it comes to the cold refrigerant. That is, it is converted into cold refrigerant. It is coming to the evaporator coil. It is the evaporator exchanger. So then the cool air is coming to the inside of the locomotive. By the fans are working in the blower. The cool air is coming to the inside, and the condenser water is going to the outside. This is just a schematic. Okay, sir. Cabin parts. This is a compressor, and this is a blower with the motor is there. Heater is there, and the evaporator coil is there, and then condenser fan is there, and the condenser coil is there. The compressor, blower with motor, heater, evaporator coil, and the condenser fan, and the condenser coil is there. The condenser fan with the motor is here. Just a view. What is the refrigerant we are using in our cab AC is R407C. What is the function of this is? The refrigerant referred as the blood of the system or cooling system. The refrigerant is very, very important. So refrigerant referred as the blood of the system. Refrigerant are a special fluid used in a cooling and heating system to transfer heat by repeatedly evaporating and condensing. Okay, refrigerant are a special fluid used in cooling and heating system to transfer heat by repeatedly evaporating and condensing. The refrigerant has a very low boiling point, which means that it changes from liquid to vapor at low temperature. This refrigerant is moved around the air conditioning system via compressor. Okay, this is a cooling system how it is circulates. So what is the refrigerant is R407 is a mixture of hydrofluorocarbon used as a refrigerant. This is the refrigerant nowadays we are using in cab AC. It contains a combination of blend of R32 23%, R125 25%, R134 52%. This is the percentage in the R407C. Okay, this is the combination for this R407C. Replacement. Previously, R22 is used in existing refrigerator since R20 leads to ozone depletion is there. So we are not using this R22 nowadays. We are using only R407C only. The compressor. So compressor is doing a very important functioning. The compressor acts as the heart of the system. It continuously pumps the refrigerant through a large copper loop. Okay, the compressor acts as the heart of the system. It continuously pumps the refrigerant through a large copper loop. This allows the refrigerant to enter into the compressor as a warm, low pressure vapor and leaves as a hot and high pressure vapor. Okay, this allows the refrigerant to enter into the compressor as a warm, low pressure vapor and leaves hot and high pressure vapor. It will come out. This is the compressor. We are using this as a scroll compressor. We will say normally this is a scroll compressor. How the compressor works means the scroll compressor has a one scroll or a spiral orbiting on the path defined as the matching fixed scroll. This blue one is a fixed scroll. How it is functioning is this is the blue one is fixed scroll. The scroll compressor has one scroll and a spiral orbiting on the path defined by a matching fixed scroll. The fixed scroll is attached to the compressor body. It is a fixed scroll, it is attached to the compressor body. The orbiting, this orbiting scroll, the orbiting scroll is coupled with a crankshaft on the on the orbits rather than rotates. So it is just like a crankshaft. Four-stroke engine, very vehicles like crankshaft, how it is rotating like that. There is a crankshaft will be there. So it will rotate like this, and this is the way the compressor pumps. The orbiting motion creates a series of gas pockets traveling between the two scrolls. The orbiting motion creates a series of gas pockets traveling between the two scrolls. Between the fixed scroll and the moving scroll, the gas, this is a compressor, it is takes place inside this. Okay. On the outer portion of the scroll, the pocket draw in gas, then moves into the center of the scroll. Normally, when outcoming means it will come to the outward center of the scroll. On the outer portion of the scroll, the pocket draw in gas and then moves into the center of the scroll, where the gas is discharged. As the gas moves into the increasingly smaller inner pockets, the temperature and pressure increases to desired discharge pressure. Whenever scroll takes place, the temperature increases and the pressure also increases and desired discharge pressure. You can see what is this is scroll compressor. This is the first gas and this is a shade. This is the first shade, the gas entering shade. Second one is the open shield of the gas drawn into the spiral. This is the second shade. It is not visible. The second shade. Third one is gas is compressed. This is the gas. This portion is the gas is compressed stage. Fourth one is discharge. It is there. The discharge pressure and reaches at the center point. From the center point, the continuous suction and discharge takes place. Okay, scroll compressor வந்து stage மாறிக்கிட்டே இருக்கும் one by one. So this is the first portion. This is second. The gas is third compression. This is the discharge pressure reaches at the center point. Then it is continuous suction and takes place. From the center point, outlet is coming. This is the view of fixer and moving scroll. Just for information. Yes. The condenser, when the refrigerant is hot, high pressure vapor via compressor, it moves to the condenser coil, which is then cooled down. When the refrigerant is hot, high pressure vapor via compressor, it moves to the condenser coil. That is a condenser, which is then cooled down ion. The condenser coil have a small metal fins on them that draw heat from the coils. The condenser, like we are having the condenser fan, the condenser coil, the small metal fins on the outer surface, like all other motors also. And then that draws the heat from the coils. The condenser coil have small metal fins on them that draws the heat from the coils. The condenser fan motor blows air in the fins. The condenser fan continuously work பண்ணிட்டு blows air into the fins, which helps the vapor to cool down. Due to this cooling, the refrigerant is converted into hot liquid and then moves into the expansion valve. The first stage is compressor pumps to the condenser. That is the condenser chamber, heat exchanger chamber. Then it goes to the third stage is expansion valve. You can see the expansion valve is a function. This is the condenser motor. The condenser fan, motor fan is there. This is a thermal expansion valve. From the compressor, it goes to the condenser evaporator. Then it comes to the thermal expansion valve. The thermal expansion function is the main way the refrigerant is cooled. The thermal expansion cooled the thermal expansion. When the refrigerant is a hot liquid, it passes through the valve at a very high pressure and then comes out in a cool mist. This is able to happen due to the fact as the gas continues to expand, it is naturally cooled down. It will enter, after then the pressure will reduce, then it will come to the cooling stage. You can see this is the working of thermal expansion valve. The pressure pushes the diaphragm, forces the pin to open the valve, allow more refrigeration. That means this is the refrigerant, the compressor, that is a compressor. This is a thermal bulb. This is already connected in the outlet, that is a refrigerant, that is a refrigerant chamber, that is a evaporator coil side. It senses, it allows, due to this sensing, it allows the diaphragm to move up and down according to the temperature. It will function. Then according to function, then the refrigerant will go inside, and the valve will open. The refrigerant will go inside. Then the refrigerant is out to the evaporator coil. It goes to evaporator coil. So before that, compressor, condenser, then this thermal expansion valve. The thermal function is very important. Due to this thermal bulb, there is some pressure is there. Due to the pressure change in the expansion line, so it acts, the diaphragm operates, and the diaphragm operates, then it's open, the path will open, the refrigerant condenser air will go into the inside, then the refrigerant out to the evaporator coil side will come out. Okay. This is the final, this from the thermal expansion valve, it goes to the evaporator coil. The final part of the air conditioning unit is cycle happens in the evaporator coil. Low pressure liquid now led to the evaporator coil. This is where the warmer air inside blows to the evaporator coil. Low pressure liquid is now led into the evaporator coil. If you go to evaporator coil, is a big chamber. So this is where the warmer air is inside blows to the evaporator coil. The refrigerant vapor moves back to the compressor and then the outdoor condensing unit, and then expands, it cools. The same continues, the cooling cycle is continuing. Okay. You can see the evaporator coil. This is the evaporator coil. From the thermal expansion valve, it comes to the evaporator coil. It is a pathway is very large. It is cooled down. Then it goes to the again the compressor cycle. Then condenser. The cycle rotates like this. In the evaporator coil near only, we are having the blower. Blower is there. It will flow the air to the cooled air to the inside the cabin. This is a blower motor to circulate the cooled air from evaporator coil. From the evaporator coil, through this blower only, the cooled air is coming into the cabin through that outlet part. The blower motor, this blower runner is there. It is attached with the shaft. The control panel indicator. This is the control panel indicator. You can see in the cab itself. This is a control panel. In this also, sir, when the main on, it will indicate the main on. After then, so blower on, it will indicate the blower on. The compressor on, it will indicate the compressor is on. The cool on is cool on. If any problem in the high pressure, if it is high pressure indication will come. In the low pressure, when there is a refrigerant is low, of any pipeline is cracked and the refrigerant is fully down, very less, it is come, the low pressure indication will come. This is a heater and this is a compressor trip. Any compressor trip means it will indicate on the driver desk. That is a control unit. You know. The technical description is the cooling capacity is 2 ton. It is the capacity is 2 ton. The power circuit is 415 volt AC, 50 hertz. The control circuit is 110 volt AC, single phase. The refrigerant is R407C. We already seen what is the refrigerant. The compressor hermetically sealed scroll compressor. The weight is 150 kgs approximately. Structurally, they maintain with the stainless steel construction 304. This is the 210 capacity. Power source 415 volt. Control 110 volt is the AC is the control circuit. Refrigerant already knows. Sealed scroll compressor 150 kg. Stainless steel construction is there. In many locos, we have seen the condensed water stagnate on the outlet of this, and it is falling on the driver desk also, and it is so. We have taken some action. If you run for a long time, so that this condenser water will stagnate on the outlet of the. Okay. Oh, sorry. We have taken some steps to prevent the water leakages. First, isolate the manual mode. If it is manual mode, the continuous running will be there, so that the manual mode is isolated as per our instruction. Nitrile sheet provision in AC cover. Previously, first we have started nitrile sheet providing in the AC bottom cover, because from the outlet side only first we have identified, so bottom cover. The nitrile sheet provision in the blower duct. In the blower and the pathway also, blower duct is there, and the duct also we have provided. Finally, nitrile sheet and the puff covering in. First, we have provided nitrile sheet in the thermal expansion valve. What we have seen in the thermal expansion valve, we have provided nitrile sheet in the thermal expansion valve. After then also, we got some leakages from there, so we have provided puff. Puff also we have provided. After providing this, it is actually reduced. Checking any blockage on the drain pipe. There is a from the blower chamber, the condensed water. There is a pathway is there. From that pathway, it goes to the motor side. That is the tank side. So that pathway also we are ensuring and cleaning in minor schedule, and we are ensuring. This is a nitrile sheet provision in the AC cover. AC cover bottom side. This is a filter. This is the outlet side. So we have provided the nitrile sheet like this. This is the provision. Thermal expansion valve is there. What we say is thermal expansion valve. From this thermal expansion valve also we have provided nitrile sheet on the thermal expansion valve to prevent the condensed water to falling inside the cabin. So we have provided. Over the nitrile sheet prevent the thermal expansion valve. Again also we got some leakages, and the Raybaram practice also we have gone and seen, we have identified. They are providing the puff in the in the thermal expansion valve as well as nearby pipelines. That is capillary tube like that. So we are also started providing more than 83 locos we have provided, just for information. The condenser in the another defects we have seen that the condenser fan broken in Sidwal make. We have seen that cooling is less, and that AC cooling is less, AC not working like that. So we have identified, and this blade broken is there. In this model only we got some failure is coming. So we also form also advised just for information. That is a transformer. Just 30423 on loco first when TKD said they are called as, sorry, your loco came that thermal expansion not available report. So we suddenly surprised. We have seen when dispatching date before that we have seen that AC is working from shed. and AC chart also working option, it has gone. I think in 39, like this. So that SSC called and we informed the Sidwal firm to sir, please provide. They are telling it is told sir. Before that, it has gone to the TRIPSED NDLS. That is the remarks we got. So we are given complaint also given sir. To prevent any earth fault or any cable coming out, so we have provided NOMAC sheet provided to prevent and the earth fault we have provided in the control unit bottom side. We have provided nitrile sheet. Sorry, NOMAC sheet. So that's all. Very simple only.